All right, so this last question has implicit differentiation, which means I could take the derivative of the left-hand side and the right-hand side. Remembering that, I got to time some things by dy by dx. That's the derivative of y. But first, I'm going to want to just kind of simplify this equation down first. Whenever I can do that, that always helps. So the exy, there's nothing really I can do. But I can times that by the ln of x minus the ln of y. So just using that quotient rule to break that up. And then x, and you know what? Let's even just write that as plus y to the negative 1. I could do my quotient rule with derivatives over there, but when it's that easy, I'm going to want to make that y to the negative 1. So now that I have this, I'm going to switch over and I'm going to go to a different color because this is going to be me taking the derivative. So I still got some craziness going on here. I still have a product rule on the left-hand side. My right-hand side, oh, I can't wait to get over to that side. That's going to be easy to take the derivative of. I know I've got the point g, which is e and 1 over e. So I know I can sub that in once I have my derivative. For me, it's always easier to sub the number in as soon as I have my derivative and not worry about simplifying the derivative. Simplify once I get the numbers in is easier for me. Okay, so let's take the derivative of this. So when I'm taking the derivative of e to the power of something, the first thing I do is write down what it was, exy. Then I times that by the derivative of my exponent. Now the derivative of my exponent is using a product rule again. So I have a couple of product rules in this derivative. And I'm just taking things step at a time. So the product rule says derivative of the first part, which is x, so that's going to be 1, timesing that by my second thing, which is y. And I'm going to add to that, leaving my f as is, times it by the derivative of my g, which is dy by dx. So just remember that the derivative of y is dy by dx. So that's just the derivative of e to the xy. So I'm still timesing that by ln x minus ln y. Now, because it is a product rule, I'm putting a plus. I'm writing down my exy because that's kind of my first part of my product rule. Now I've got to times that by the derivative of ln x minus ln y. Okay, so the derivative of ln x is 1 over x. So now I'm going to put down my minus sign. And now for the derivative of ln y, so remember, I'm going to kind of put it as like 1 over y. So I just read it as 1 over the function. But then I times that by the derivative of what I'm taking the ln of. So the first one I did 1 over x times 1 because the derivative of x is 1. This time I'm doing 1 over y times the derivative of y, which is dy by dx. All right, now this is equal to, okay, this was the easy one now. This is good. So derivative of x is 1 plus the derivative of y to the negative 1. So then all I'm going to have is bring down that negative 1, making it negative y, subtracting 1 from the exponent, timesing it by the derivative of y, which is dy by dx. Oh, there we go. So just took that thing one step at a time. You could definitely change colors as you go to help you figure out what I did. But on the left-hand side, there was a product rule. And then it's kind of like my main thing. It was exy times that bracket. But then even as I was finding the derivative of e to the xy, there's a second product rule in there. So it was a pretty good question. Now I just need to see how can I simplify this down. And really what I want to go for again is I eventually want to be able to isolate dy by dx. Actually, I forgot already. I don't need to simplify at this point. I can sub it in because as I sub things in, it might get easier. So I'll even write that down here. I'm going to sub that point in for x and y. I'm going to pause this because there's a little bit of writing and I don't need to say much, so I'm going to pause it, come back. Okay, so I went ahead and I just substituted in e every time I saw an x and y every time and 1 over e over, oh, I can't talk. And I substituted in 1 over e where I saw the y. Now notice I did not sub anything in for dy by dx. Those are not variables, that is saying the derivative of y. So dy by dx, I did not substitute in the y and the x because that is not a y and x. That is saying the derivative. That is what I'm wanting to find. So I have some nice things here. I mean, if you look at my first bit, I have e to the power of e times 1 over e. So I mean, e times 1 over e is just 1. So that whole first little bit is going to simplify down nicely. I've got that in a couple places here. So let's just go ahead now and see what we can do to simplify. Okay, so I did some simplifying, and what I do want to bring your attention to is right here where I had the ln of e and subtracting the ln of 1 over e. So the ln of e is 1, because I mean ln of e is like having log base 10 to 10. What does the exponent need to be? It needs to be 1. And then in the other spot, it was a negative 1 because we want just a negative exponent. We want e to the negative 1. So I'm going to have 1 subtract negative 1 there. So you can see as I go to simplify some things in, it's going to get even nicer. So I do have an e outside some brackets where I got to multiply by 1 over e. So as I start to expand these things in, it is going to be kind of nice. Now the other thing I'm going to do is where I've circled in blue, that is equal to 2. So I do know that is 2. And I'm going to bring that and I'm going to combine that right away with this e as I go to factor that inside or expand that inside. Just kind of in one step there. And we'll see what we get. All right, so now expanding that out, this kind of looks really nice. Like looking across my equation, I got some constants, the 2 and the 1s. But then wherever I see the dy by dx, it has just an e squared by it. So this is going to work out super nice. So what I'm going to want to do now is get all my constants on one side and all my dy by dx is on the other side and just collect like terms. So I won't pause the video for this step here because I don't think it's that bad. So on the left-hand side is going to be all my dy by dx's, and I know that's a common factor. So I'm just going to common factor that out right away, and then I can see I'm going to have a 2e squared minus e squared. And then when I bring that other negative e squared over to the left-hand side, it's going to turn that into a plus e squared. And then I have my 1, subtract 1, subtract 2. So that's just kind of collecting everything off on the other side. And this is going to really start to simplify down nice. So dy by dx, 2e squared, minus e squared plus e squared equals 1 minus 1 is 0, so minus 2. Okay, so my last step here then is just to divide by 2e squared. So I want to divide both sides by 2e squared so that I get my dy by dx all by itself. And I can kind of simplify this as well. And there we go. I actually get negative 1 over e squared as a final answer. So my derivative at that given point is negative 1 over e squared. So again, that is a slope. That is an instantaneous rate of change. That is my derivative. All those things mean the same thing. We got to keep that in mind. So negative 1 over e squared is a number. It is a constant. It's my slope. It's my rate of change. It's negative 1 over approximately 2.7. There we go. So that question was really good. It reminded us how to do implicit differentiation. Saw that subbing in numbers, e's over e's, a lot of just great stuff in there. So definitely go slow and just do a little bit at a time. Concentrate on what you know for one line and then see where to go with the next line. If I were to think about how do I get a final answer with this, just looking at that, it can be daunting. if I take things one line at a time, it actually worked out really, really nice.